Hi there, my name is Anne Bigalke. I'm the VP of Strategic Development at Qualitru Sampling Systems. I'll be talking about process monitoring today and sampling, specifically what is going through your pipes, some of the risks, and how to take a proactive approach to process monitoring and sampling. So today, it's important to kind of talk about what's the end goal, and that's really to understand how we can best prevent contamination in our process, both inline and then in silos, how to improve our food safety and operational efficiency when it comes to process monitoring. There's some small tools and things we've learned over time that I'll share today. The topics or agenda for this presentation, we'll start out with talking about in-process risks, so what you should be looking for in your sampling plan, how to build a sampling plan that mitigates as much risk as possible and takes into consideration product quality and food safety, sampling considerations and best practices, and then last, talking about a couple examples of operational efficiencies and cost savings when it comes to process monitoring. So when we talk about microbial risks inside your lines or in your silos, there's quite a few different opportunities for bacteria or little bugs to get into your system. The first one is when you look at the left-hand side here, it's corrosion or soiled surfaces. Without good cleaning practices or just good etiquette, you can run into situations where you have bacteria building up over time. This one here in the top middle is a valve system that hasn't been properly cleaned. So you see over time, there's a big biofilm building in there. That's then released back into your process. So without good cleaning practices, taking out different fight clamps or having just good sanitation practices, you can risk contamination. The ladle here has just been dropped enough times that you get cracks in there. The pictures here on the right show some cracks and pinholes. As stainless steel heats up and cools down, with time you'll see that the stainless steel will open up and then close. And so here's an example of a crack in stainless that allows bacteria to go in. It can sit, it can develop into a biofilm. In some cases, you might have poor welding work where you have, rough or pitted stainless steel that over time will then allow bacteria to kind of cling to the surface. You might even have contaminated air if you don't have a good sampling plan or a good filtration plan in place. When you're blowing your line to the end of your cleaning process, that might introduce contamination before you start your new run. Talking a little bit more specifically about biofilms, as this has been a hot topic for a lot of our partners lately, and they're really a challenge because it's something that is just really ongoing and they're quite difficult to identify and difficult to manage. So biofilms are when you have a piece of polished stainless steel like this picture here. Stainless steel naturally has some rough surface. You can get different grades, but here's an example of one that's well polished. You still get bacteria clinging to the surface. It's sitting long enough or if you don't have good controls in place. The challenge with them is they can be resistant to heat and chemicals. So you can have good practices in place, but they might still cling to a surface. They can develop quite quickly over time, from hours to days, and in some cases they might even sit on the surface for several weeks. Common sources where we see biofilms being laid and causing issues. Number one would be in silos. Products sitting still is more likely to sit and cling to surfaces. Silos, tanks on the farm. Bulk tanks are tanker trucks. They're sitting for quite a bit of time, so that's a place that you want to be looking closely if there's a biofilm building. Additionally, we see them in milk transfer lines and then gaskets, seat valves, and other bodies, which can be quite difficult to clean and require often kind of a more hands-on approach for that cleaning process. The big challenge with that, beyond just being hard to identify and hard to remove, is that they can introduce organisms that can survive pasteurization. And that could then lead to off flavors or to your product quality degrading over time and faster than you had originally planned. It can also introduce post-pasteurization contamination, those gram-negative bacteria that create more spoilage. So we have a picture here that I think is a really nice illustration of what that looks like. You have bacteria clinging to a surface. especially when you have cracks or pinholes, but it can also just be that polished stainless. Over time, it builds a shield, and it will release small bits over time. It could be spores, it could be different types of contaminants into your process. The challenge is that it's not uniform, so it can be difficult to identify where that biofilm is coming from and to know exactly how it's going to impact your product quality. So it is something that is a challenge. It's an ongoing challenge, and especially challenging for us in the dairy industry, because dairy is really a perfect growth medium for bacteria. You have quite a bit of water, oxygen, you have food, and you have a high content of bacteria to start out with. So it's really the perfect growth medium for bacteria, which can be good, but it can also be challenging if it's not the type of bacteria that you're hoping to introduce into your final product. This is another picture of polished stainless steel. You get really close and you can see how it is pitted. It's a bit of a rough surface. Easy for something like Pseudomonas to cling to that surface, which would then impact your product quality in the very end. We break down bacteria into kind of two big groups. You have your pathogens, which create sickness, and then you have your spoilage, which creates off flavors, and that impacts your shelf life. Both you want to have good controls in place, and we'll talk a little bit more later on about how to create a plan to look for both of those types of bacteria, but that's really the major risk that you have there. Is you want to make sure that you have control on both, and if you can, identify them early to be proactive in how you react to that. Going back to the spoilage and types of bacteria, what is the impact on your final product quality? So for the non-microbiologist, we'll keep it really simple and just really focus on what does that mean in terms of your flavor or the taste, the shelf life of your final product. With biofilms or other deformities in your process, you risk having thermophilic bacteria. That passes through your pasteurization or your kill step. And that's where you have risks in terms of changing the flavor. And that can be a challenge if you're having a long shelf life, even short shelf life, if there's disruptions in your transportation process, or if you're trying to build conformity of your product across several sites. It's something that you want to make sure that you have good controls in place to identify those types of bacteria post-pasteurization, recognizing they could be coming before your pasteurization as well. You can also risk having pinholes, cracks, biofilms in your pasteurization step as well. And that can then also create other off flavors and defects in your final product. So you want to make sure that you're understanding that there's different types of bacteria being introduced in your process. And it can be at that kill step, but it can also be introduced ahead of them and then pass through that final step as well. So how do we mitigate having biofilms, cracks, or other deformities in our process? Number one, you want to make sure that you're proactive in having a good sanitary or hygienic design in your process. That comes down to your equipment, your layout, and that you have everything properly polished in place. You have 3A or EHEDGE certification. But that first step is really critical to make sure that you're not introducing risks just into the design. Next would be making sure you have good, effective cleaning and sanitation steps in place. So that's running, high enough temperatures, having correct concentrations of your chemicals. It could also be just hand hygiene and employee hygiene. The next would be having proper hygiene and training for your SOPs and your staff. That's making sure that everyone is having good awareness and training around the right practices. We see this often when it comes to sampling, in that, you might be grabbing several different materials and your hands are not completely clean, and that can disrupt your practice, your process in place. Even when you have good sanitary design, effective cleaning, and good training and hygiene with your staff, you can still risk having contamination, and often at low levels, which is still quite challenging for you to face with good product quality in the very end. So what you want to do then, so you have good sanitation, hygiene, training, design. You want to make sure that you're validating and verifying that as you're going through your process. We break that down into 3 different categories, and having good process controls to validate your positive steps in place. The first one is looking at your raw receiving handling. So that's any milk coming into your plant. It could be other materials as well. Maybe you're receiving cream, whey, or other water or other ingredients. You want to make sure that you have a good plan in place to look for what is coming in, both from a total bacteria level, but you could even look at something like lab pasteurized count, coliform counts, butter, fat, protein, whatever. If you have a solid sampling plan, good process control, you're going to have, you're going to prevent having garbage in, garbage out. Good program in place there. The next is looking at your system hygiene. That's really making sure that you don't have any biofilms, cracks, or pinholes anywhere in your process, that your sanitation is properly cleaning your lines. So this is especially critical when you have aging equipment. So as over time, that heating and cooling will allow the stainless steel to open up in some cases. Poor welding can get worse over time. So you want to make sure that you have good controls around some of those specialized pieces of equipment. We see more and more plants moving towards having more sampling spots, especially for coliforms or spores, when they have filtration systems. So if you have any water recycling or if you have whey filtration, you want to make sure that you have good controls, because it can be quite difficult and timely if you have to go through and inspect every single one of those membranes. And then the last is really the most critical step, is that post-pasteurization contamination step. You want to make sure that you have good controls after the pasteurizer. Again, we've seen situations where you have cracks, biofilms building in your pasteurization. Without good controls in place, there's really no way to identify if it was coming from the pasteurizer or anywhere between there and the filler. So we say try to separate all your equipment between that final kill step and then that final filler. Pasteurized tanks are especially important to make sure you don't have biofilms building over time. So how can in-process sampling help? Beyond just looking for cracks, pinholes, and biofilms, you want to make sure that you're meeting your regulatory or customers' requirements. Whether that's HACCP, BRC, SQF, you're going to have requirements for your final product quality. The only way to really have good control on that final piece and your final product is to have good controls from the very beginning of the process. And that goes to looking at your pasteurizer and then any critical step before that as well. Again, it allows you to be proactive, so you don't want to wait until there's an issue. You want to understand, is your equipment properly cleaned? Is it meeting your specifications? That allows you then to have the proper corrective actions in place if you ever need them. And hopefully if you have a good sampling plan, you don't ever have to get to that point where you have to use a corrective action. It allows you to gain control over your component levels. So especially when you're working with butter, cream, but even with fluid milk, you want to make sure that you have accuracy when it comes to your components. Without having a representative sampling plan and good understanding of the true components from the very beginning of the process to the very end, bad sampling might allow you to get to data that isn't representative of your entire process or your entire batch. Looking at operational efficiencies, if you're taking good sample data, that allows you then to understand, are you running at the right amount of time? Can you push your process to add another hour to the very end? What is going on with your pasteurizer after the first 3-4 hours? Are you seeing changes in that bacteria level? Are you seeing bacteria build up over time? What is going through your process? Without having good sample data between pieces of equipment, you really have no idea how that process changes over time. And if you can modify that, extend it, or if you need to shorten it. And then last is, sampling, you can look for cost savings. So that goes to, running longer times or shortening your times. That can allow you to have longer times for people to work on the floor or shorten that. But you can even look at ways that you might be wasting product. So for example, if you have product running through a valve, before you collect that sample, what are ways that you can keep that product in your tank, not wasting that product before going through that sampling process? Talking about a couple of case studies to kind of illustrate how sampling or process monitoring can help improve product quality. The first one is there was a fluid milk plant that was having some spotty issues. They were having variable total plate counts that would go up and down kind of week to week, and they weren't able to understand why sometimes they could meet their shelf life, and then some weeks they would be 5 or 10 days under. So they needed to gain some control so that they weren't losing product and losing customers. Because they weren't quite sure where this was coming from, they thought in their final product they put strategic sample points from the very beginning of the process to the very end. They had about 10 different sample points, but they really focused kind of on that pasteurization step and having several steps after that. By sampling before the pasteurizer and after the pasteurizer and a few steps in both directions, they were able to identify that they had spikes at the pasteurization or the kill step. What they did is they took that apart and they found there were cracks in their pasteurization in those plates. They replaced them, put them back in place, but they continued to take samples on a daily basis to prevent that kind of issue from coming again. So that's a good example of, without having in-process data, you really have no idea what's going through your equipment, even though you assume that the pasteurization step is working correctly. In some cases, you don't have all the data with just time and temperature. This is an example of a filtration, a whey facility. They supply a product into China, and they have very strict regulations on their spore counts. And some packages, when they got inspected, would have higher counts than others, and they weren't able to identify why that was an issue. If it was coming from the process or transportation or the ingredients. So what they did was very similar to the fluid milk plant. They put strategic points throughout their process, took samples, and then they were able to identify a couple tears in some of their membrane systems and just focus on that section rather than having to tear out all of their membranes and inspect them, which would take them days, if not weeks. So it saved them time, it allowed them to get more accuracy, and they have kept those points in place. They check for spores, coliforms, EB, any other type of hygiene indicators to make sure that they're within spec, and if they're not, they can replace specific filters very quickly without having to go through their entire process. Something important to think about when you're looking at your sampling plan and you're wanting to gain some control over your equipment and your hygiene is to think about what is your sample size. And the best place to start is to think about what is the end goal. So are you wanting to understand what's in a tank? Are you trying to understand what is your product quality from the beginning of the process to the very end for that entire day, or longer if you're running longer than that? So we kind of have two different categories when it comes to how to collect your sample. The first one is grab sampling. So that can be a small sample, we call it a snapshot. It would be maybe, for example, just a 60 milliliter sample taken off of a silo, or it could be inline as well, but it tells you what is the product in that moment. In a tank, ideally you're agitating so that the product is more thoroughly mixed. It could be a bit more representative to the entire batch or that entire tank. In a line, it's just telling you what's running through that line in that moment. In a line, if you're trying to get more representative data, you maybe want to consider a larger sample. Rather than having 60 milliliters, you're going to want to grab slowly from the very beginning to the very end of that process. So that could be a larger sample size, so maybe like 2 liters, more or less, but it's more about time and duration. That it's going to be slowly collecting from the very beginning to the very end into that sample container, and it's going to tell you what is your process, what's going through that piece of equipment from the very beginning to the very end of that day. Different from the grab sample, which is kind of what's in that tank, what's in that sample point at that moment. We see plants using a combination of these two. Often grab sampling is used on silos. Representative is used inline, especially after critical points, such as tanks. You want to see the beginning and the end of that tank, so you can grab a small sample. After the pasteurizer is pretty critical. We see quite a few that are moving towards collecting spore counts, coliform, EB after pasteurization, because they really want to make sure that their pasteurizer is working correctly. As well as tanker trucks. It's a really great way to be able to look at your butterfat counts right off of a tanker truck. This is an example of a cheese and whey plant. They had variable microdata going from the whey facility over in one line into a filtration and powder plant. and they were concerned about the bacteria levels because that's how they had their payment plan set up, because that's the final customer was looking for very low spore counts, and just bacteria counts in general. So they had different sampling methods, which created a lot of confusion or disruption in terms of who had the right data. So what they wanted to do is to put a representative sampling system in place. And because it was for bacteria, they wanted to make sure that it was as clean or aseptic as possible, free from contamination. So they put a representative sampling system in line. They collected that over a period of time, and it was aseptic, so they knew that the bacteria levels would be correct. So today they use that same sample data, that 2-liter collection bag, to pull their payment sample, and they both agree on the process, which makes that payment process a lot easier. We talked about cost savings, and this is something that's a bit unique when you talk about different types of sampling systems or different sampling plans. In some cases, you may be using a sampling system where you require to have product running through, or you're requiring, steam to be run through your lines to clean or sanitize. This specific plant had a system where they were wasting product through valves for about 5 seconds to 15 seconds, depending on the type of product they had sitting in the tank. Often it was ingredients, or it could have been fed into formula. They found that running the product through on average for 10 seconds cost them about 50,000 euros over the year. So by putting a closed system in place, they had savings both in terms of cost, but then also they didn't have to run steam plant, and they didn't have to have their employees have to get all guarded up to collect that sample. So what are some considerations that you have when you think about sampling? The first one is you want to ask is, does the sample need to be truly aseptic? What decisions are going to be made with this sample? Next, if you decide that you need to have a clean sample that prevents contamination into your process or into the sample valve or sample vial itself, is it cleanable? How easy is it to clean? Do you have to take it out of place? Do you have to require steam to clean it? Here's just some examples of different types of cleaning inefficiencies when it comes to sampling, and some considerations. Even if you're running steam through your lines, you still might have biofilms or cracks running through your process. And then the last one, which is pretty important, is it easily replicatable by your entire team? Can anyone take that sample? If you can't, then where is there risk in that sampling process? And how do you minimize that risk? Does that require having pre-sterilized equipment, or does that require that you make sure that you have a plan in place that requires additional steps, or do you have everything kind of already laid out for them? And one important thing that we like to say, your test result is only as accurate as your sample. So why go through the process of having a thorough testing plan when you don't have a good sampling system and a thought through sampling plan in place, or even sterile or aseptic equipment in process? In summary, when we talk about process monitoring, you want to be looking for biofilms, cracks, pinholes throughout your process. You use that by gaining control with sanitation and hygiene, and you want to make sure that that's a conversation that involves both quality and food safety with engineering and the quality team as well. If you look for different deformities in your process, you want to start at the very beginning to understand what is coming into your plant, whether that's total bacteria count, coliforms, EB, what is entering in. Check your critical control points, really starting at the pasteurizer, and then any point between there and the filler where the product changes or it sits, or anywhere before that might be aging or have risky equipment or highly specialized. So that would be any filtration. If you have a separator, a homogenizer, you want to be checking those as well. If you go through and evaluate the risk in your sampling plan, that allows you to understand what type of equipment that you really need. Does it need to be aseptic, or can it just be a sanitary designed sampling valve? What risk does that cleaning process have when it comes to the quality of your sampling? And does that introduce potential contamination into your process or into your sample itself? And then what is the sample size that you need? Do you need a representative sample, or do you need to have a quick grab sample? For more information, I encourage you to come to our website. If you go to qualitru.com, we have resources, more information about biofilms, cracks, pinholes, how to monitor your process. We also have our sampling solution available on our website, but you can email me as well. I'm happy to talk about different sampling options and get you connected with partners to get more information going. Thanks for your time.